Hi, today in this video we will be discussing converting the given epsilon NFA into its equivalent DFA. So this I think have one more video already I have done on this epsilon NFA conversion from epsilon NFA to DFA, but I will discuss some more important problems in this video. Let us take example, convert the given NFA to its equivalent DFA. Look at when seeing a transition diagram, it has epsilon moves, then you can say epsilon NFA, right? In this I have every zeros, any number of zeros accepted by any number of ones accepted by any number of twos, that is any number of zeros accepted followed by any number of ones accepted followed by any number of twos, right? So this is a regular expression accepted at this diagram, this transition diagram. Then you have constructed epsilon NFA for this. It is easy for you to construct epsilon NFA. So then you can convert it into equivalent DFA. Before to this, I'll recall again what is a epsilon closure. There is one more terminology is very important. I need to compute all E closure for each of the state. E closure of the state. That means any state you can, without taking any input from starting state to final state, then you can say E closure. It is not taking any input from start state to final state, or it can a set of state which are reachable from Q without taking any input is called as a epsilon closure. Let us see how to find out the E closure of each of the state. E closure of each of the state. Right. Look at that E closure of Q naught, then which is equal to Q naught comma Q1 comma Q2. Then when you start from the Q naught, without taking any input, can able to reach Q1, you can also reach to Q2. That means starting to end Q naught, Q1, Q2. Then E closure of Q1 is, it is starting from here, right? Then Q1 to Q2 you can able to reach without taking any input. That Q1 and Q2. E closure of Q2 is only E Q2. We are not moving into any of the state. You will be in the same state. So that itself is the E closure, right? So I hope you understand this E closure computing. Let us move to the conversion. So conversion procedure, all of you know, starting state of Q naught will be the starting state of DFA. So starting state of NFA will be the starting state of DFA. Before to that, you need to find out the E closure of all this. Then you can find out the transition of each of these state, each of the input, not a state, each of the input. What are the input in this case? In this case 0, 1 and 2. Let us move to the finding it. Now we will obtain a delta dash transition. Let us E closure of Q naught, you know already. E closure of Q naught is Q naught, Q1, Q2. Call it is as a state A. Call it as a state A. Why this call this as a state A? Just alias name as given it for this, because simplification for further use, right? So now finding the transition for this state A. State A is nothing but Q naught, Q1, Q2. So on delta dash of A comma 0, that means E closure of Q naught, Q1, Q2 on 0, we can split like this: Q naught on 0, Q1 on 0, Q2 on 0. All you have to take the union. Then Q naught on 0, it will go to Q naught itself. it will go to Q0 itself. Okay, then is that Q1 on 0, there is no transition at all, there is no transition at all, there is no transition at all on 0. Q2 on 0, there is no transition at all. So then finally you will get E closure of Q0. Finally you will get E closure of Q0. Then E closure of Q0, you already know it. You can record it like this: Q0, Q1, Q2, which is similar to already you are finding it the state A. You can same as state A. You will rename as it is, right? So 0 is over. Then what is the next input? 1 on A, right? On A. Delta of A on 1. That means E closure of Q0, Q1, Q2, nothing but A. A is representing these states. On 1, again you can split like this: delta of Q0, 1, union delta of Q1, 1, delta of Q2, 1. When you look at this diagram, there is no transition on Q0 on 1. There is no transition on Q2 on 1. Only have transition on Q1 on 1. It will go to the same state. You know already E closure of Q1. That means Q1, Q2. Then which this obtain new states which is not similar to A, you can call as a state B. You call it as a state B. There is another input is on, so 0 is over, 1 is over, 2 is there, right? Delta dash of A comma 2. So that is A is nothing but representing this Q0, Q1, Q2. On 2, again you can split like this: Q0, comma 2, union Q1, comma 2, union Q2, comma 2. So as you see that this diagram, there is no transition on Q0 and Q1 on 2, only on Q2 on 2 will be there. Then that is Q2 on 2 will go to the Q2 itself. E closure of Q2 is what? Q2 only. Q2 only. So we call this is not similar to A and B, capital A and capital B. You call this as a C, right? From A, in taking a transition on A, you will get the new state B and C. Then you have already computed the transition on Q0 on A, it will go to A itself. Q0 on 1 will go to state B. Q0 on 2 will go to state C, right? From A you finding the new state B and C. Then again you have to find out the transition on B on this input 0, 1 and 2. Let us see it in the next slide, right? So again now you will find the transition on state B and C for each input. B on 0, B is nothing but Q1 and Q2. Q1 and Q2. Again you have to split like this. When you split like this, so 0, there is no input on this state. There is no transition on this state. Q1 on 0, it will not have any transition on 0. Q2 on 0, there is no transition at all. That will be pi. So E closure of phi is pi itself. We call this as a state D. If for time being keep that is a state B. Then B on 1, again you have to split like this, finding it. There is Q1 on 1, you have a transition, it will go to the same state. So Q2 on 1, it will not go to any of the state, that will become phi. Then E closure of Q1 is Q1 and Q2, which is similar to B itself, state B itself, right? On 2, B on 2, again you have to finding the transition. In this Q1 on 2, there is no transition. This will be the pi union delta of Q2 comma 2, that is have a transition. It will go to the same state Q2. You know already E closure of Q2 is Q2 itself, state C, right? Which is similar to state C. Rename it as it is, right? So B is over, A is over. Then what is the next new state? C, right? Next new state is C. Now we will find obtain a transition for C, right? Delta dash of C comma 0, E closure of Q2 is Q2 comma 0. There is no transition at all. There is no transition at all. Q2 will not have a transition on 0, 1, right? It has transition on only 2. That means it is go to the dead state. That means a phi, right? You can call this as a state D, right? So then C on 1, again there is no transition at all. That will also there is pi, that pi closure of pi is pi itself. You call already have renamed that pi as a state D, right? On 2, let us move to the last transition. Okay, see on 2, we have transition, it will go to Q2 itself. E closure of Q2 is Q2 itself. We already that name as a C, right? We name as a C. We have not get any of the new state after this. So except D. D is it is a nothing but there is a dead state or rejecting state that itself is rotate any combination of 0 and 1 that has come. Let us, so once that the process is over, so there is no more state as obtained from this C, you can stop the process. So you have to start constructing a transition diagram. Eon 0, I'll show all this. Eon 0 it will go to A, Eon 1 will go to B, then Eon 2 will go to C. From A there are no state has come, as you seen in the all this explanation in the beginning. Then beyond 0 it will go to D because it is rejecting state. Beyond 1 will go to B itself. Beyond 2 will go to C. C on 0 and 1 will go to D. That means it is a dead state. Then C on 2 it will go to C itself. Then D is as a dead state. There is no more state transition at all. All this combination will come here itself, right? Even that is there is one transition is missing, that is right. So when it is take, there is 2 is missing in this input, 2 is missing, right? Okay, so all state have a transition 0, 1 and 2. B is also 0 and 1, 2. Then C also 0, 1, 2 transition. Then D also has a 0 and T. In this case, I made it all the A, B, C at a final state. Why this is made it as a final state? All this is A is final state, B is final state, C is also made it as a final state. Look at this explanation as given. A Q0, Q1, Q2, in which final state Q2 lies in A as a final state. Why? Q2 A is representing these many states. So in this group Q2 will be there. Q2 is the final state of epsilon NFA. Then A is also become a final state. Then why the B is final state? Q2 here also there in this group, B also final state. C is also already is Q2 is the final state of NFA epsilon NFA, then Q2 C also final state, right? So because of this reason, any one of the final state lies in the obtained state of DFA, then that becomes the final state of DFA. In this case, all of them are, all the A, B, C are final state of DFA. Then what is M here? M is nothing but 5 tuples. So Q is A, B, C, D, sigma is 0 and 1, initial state Q0. That F is C is nothing but A, B and C. So these are the 3 final state, okay, in obtained DFA. I hope we understand this concept. Let us see some more problem in the next video. Thank you.